Hi everyone, this is a solution for problem number 10. We have the same hammers in the last problem. It weighs 5 newtons, but this time both cable segments are inclined, so we have a little more mathematical, few more mathematical operations to do in this problem. And the other thing is that we've got one ratio, the 2 over 3 to the left, and one angle, the 53 degrees. So we want to solve for the unknown tensions in both segments of our cable system. So TAB and TBC. All right, I'm going to go ahead and make this nice and big so that I can sketch my free body diagram right on it. And just in statics, it's a really good idea to draw things bigger than you think they need to be. Okay, all right, let's put it about like that. Okay, so we have either a ring or a movable pulley. Either way, it's connected in some way to cables. The cables have a width, and I want to cut through all three. Do my little cut planes. And in statics, I like to do my cut planes with these dashed lines. Then sometimes I do the scissors just to emphasize. In upper level courses, I tend to use an engineering cut line like this. So if you see that, it means the same thing. I don't exactly even know why I do it differently in the different courses, but I just do. Okay, and then all we need to do is represent the internal forces. So we have a pull of 5 newtons that's given to us in the problem statement. We have a pull of the tension in cable segment BC, inclined at 53 degrees. And I'm going to go ahead and just do this in components because I know you're pretty good at this operation by now. So this one's going to be TBC cosine 53 degrees because it's adjacent to 53 degrees. This is TBC sine 53 degrees. And if you're not able to determine which trig identity is to be used pretty quickly by now without almost like not even almost going on autopilot, please get help from me or a TA or a tutor. Um, the expectation is that we got to do those pretty quickly moving forward. And on the other side, I of course have another unknown tension force, which I'll call TAB, the internal force inside that segment of the cable. And it is inclined at a 2 over 3 angle. So I'm going to do my Pythagorean theorem really quickly. So 2 squared is 4, 3 squared is 9, 4 and 9 sums to 13. And so this hypotenuse is root 13. Breaking my TAB into its components, right? So I have an upward pull, I have a leftward pull. I'm being kind of lazy with my bounding boxes, but we can pull them in there if you want. There we go, there we go. And the upward vector is the short leg of the triangle. So I'm going to do 2 over root 13 TAB, and the long leg is a 3 over root 13 times TAB. Emphasize again that if you're given ratios, use ratios. If you're given angles, use angles. And this example is a perfect example of how that would all play out. All right, and once we're in this mode, we aren't really paying attention to this, wrong color, sorry, to this anymore, right? This was how we got the components. We're not paying attention to this. And so how many forces do we have in the system? We have five. Okay, so 3 vertical and 2 horizontal, considering all those components. And we're ready to set up our equations of equilibrium. So the summation of forces in some direction equals 0. And what direction seems to make the most sense? So I'm scanning my system. I'm looking for an easy solve. Okay, and first of all, this is the only number that I've got. So let's check this way first. I've got 2 unknowns. So I'm not going to make any headway if I write that equation. And if I go this way, and do summation of forces horizontally, I've got two unknowns, but I can express one in terms of the other. So let's go ahead and do that one first. All right, so I've got 3 over root 13 times TAB is equal to TBC times cosine of 53 degrees. And kind of thinking ahead, right, I'm going to have both in this other equation. I have to solve a system of equations, so I'm going to go ahead and just express one in terms of the other. I'll just choose TAB arbitrarily. On the other side, root 13 over 3 times cosine 53 degrees, all that multiplied by TBC. Let me double check my algebra and make sure I don't make a mistake. Okay, that looks good. I've burned through my first equations of equilibrium, and when you do this, again, please, this is so important. Tell us what operation you're doing and then do it. Okay, if you just give us these equations, we kind of have to read your mind, and we don't know if you're using this coordinate system or maybe this one or something else, especially when they're errors. Um, if you tell us what you're doing, you'll find that we're much more favorable to partial credit versus having to play detective. Okay, summation of forces in the y direction equals 0. I'm going to set my ups equal to my downs. So I'm going to say 2 over root 13 times TAB. I'm going to actually just leave space there because I'm about to substitute this in. Okay, but let's finish the equation first. 2 over root 13 times TAB. And then we're going to add sine 53 TBC and set that all equal to 5 newtons. The ups equals the downs. You could also use signs if you wanted to. So you could say like upward is positive. And so you'd be a positive sign, and a negative sign, set it all equal to 0. And then when you rearrange, of course, you'll get the same thing I have here. Okay, let's go ahead and put this term in the parentheses. Times cosine 53 degrees times TBC. And one of the nice things about using these ratios is a lot of times your radicals will cancel out, and they did in this case. I'm going to factor out TBC, just thinking ahead to my calculator operation. So I'm going to have 2/3 times the cosine of 53 degrees plus the sine of 53 degrees. Okay, factor out TBC, set that equal to 5 newtons. And I'll go ahead and run this through my calculator now. I'm going to start with my most complex terms. So I'm going to take the cosine of 53 and then times 2 divided by 3. Add to it the sine of 53. And that 1.199 is all this stuff in parentheses here. What I want to do is put it in the denominator of the other side. So to do that, I should just do x minus 1 in my calculator, and then I multiply out by 5. And I get TBC is equal to 4.17. Well, I'll do it the long way. 4.167 newtons. Okay, and the sign is telling me tension. So if I had a negative sign there, that would be compression, which would mean we had a calculation error. And then for final answer, we want to round down to 3 sig figs, so 4.17 newtons is my final answer. Now, if this problem had another part, and actually it does, so when I go plug in up above, I want that 4 sig fig. So that's why I'm writing them all down, so I have a record of all of them in my written work. My calculator, of course, is storing them all. Do you see how I have fixed 6 up here? So what that says is that my calculator is telling me 6 digits after the decimal point. It's on engineering notation, right? So there's all my exponents there, e to the minus 3, which is what you need to also do for this class. So my calculator is storing all the digits, but also in my written work, I want to convey these 4. Okay, and now we have to go back and solve for TAB. So we're going to jump back to this equation right here, and we're going to plug in. And let's pretend like I was doing this in an exam situation. Man, I would really love it if this was an exam situation. If you numbered your work like this, then I would know where to start and where to go, like when it goes like all over the page like this is about to do. So that's just kind of a pro tip to make your professors happy, and happy professors mean more partial credit oftentimes. So TAB equals root 13 over 3 times cosine 53 degrees times 4.167 newtons. Let's move that out of the way a little bit. Okay, great. All right. And so this way, regardless of whether or not my calculator is keeping all these digits for me, or whether I just go back and like I'm checking my work and I just plug this into 4 sig figs, I can still get the amount of accuracy I want, which is 3 sig figs. Because I have this in my calculator, I'm just going to keep that digit and keep on multiplying. So I'm going to divide by 3. I'm going to multiply by the square root of 13. And I'm going to multiply by the cosine of 53. And I'm going to get TAB. Ah, is equal to 3.014 newtons, and this is in tension. That positive sign confirms my assumption, which better be true because you can't push on a rope, that that rope is in tension and not in compression. So you got a negative sign there, you've got an error to go find. And then for my final answer, say 3.01. Okay, so there's my final answer. Thanks for tuning in.